This week we're gonna continue talking about system design activities. Just a reminder of the context and the stage that we are at the moment. We talked about the requirement engineering stages, including requirements elicitation and analysis. And now we're talking about the system design stage, which is the closest to the requirement engineering stage and precedes the detailed design or the low-level design. So the general activities, the high-level activities that we have in system design include identifying design goals, and defining the initial subsystems, and refining the decomposition or the design of the subsystems in several iterations in order to meet the design goals. Now, more details under the defining the subsystems is what we're going to talk about this week. So we did talk about defining the design goals, and we talked generally about the decomposition or defining the subsystems. Now we're going to talk about more activities related to defining the subsystems. And we're going to start with the mapping of the subsystems to hardware and software platforms. So nowadays, most systems are distributed, which means you would have the subsystems or the components of the system running on different machines. So that's where the term distributed come from. The components are distributed on multiple machines. Okay. So these machines obviously need to communicate with each other. So this component, some sort of connection, either through intranet or internet. So some connectivity between these devices are needed so that the components running on them can communicate with each other so that they would run together as a whole system. So the decisions related to that would include the number of machines. Now, we're talking about machines, either physical or virtual machines. The environment on those machines, including the operating system, the type of database management system, and so on, the environment that is running on the machine, and the deployment of the subsystem to which machine. So which of the subsystems that we identified as part of our system would run on which of these machines. And then finally, how are these machines are going to be communicating with each other? And how the communication between the subsystems, how is it going to be happening? Okay, which protocol is going to be used? Now, we see, luckily, we have a deployment diagram from UML that is a standard way to represent these decisions in a visual or in a diagram or like a figure, kind of a visual way. So the deployment diagram would look like this. There are three main elements in the deployment diagram. The first one is a node, and it would be depicted as a like three-dimensional box like this. Okay, not a rectangle like two-dimensional rectangle, it's a three-dimensional box. And that node represents either a machine or device or an execution environment. Okay, so here we have four boxes indicating four machines. One of them running Mac, another running PC. Here, this one is running Unix, and this one is also running Unix. So these boxes or these nodes indicate the devices or the machines. All right. The second element in the deployment diagram is the artifact or the component. Now you would likely recognize this icon that we learned about when we talked about the component diagram. So this icon just represents that this is a component or a subsystem. Okay, so that subsystem would be running in this node. In this depiction, this is the general web server architecture. Okay, web server, as general web server application, a general web application that connects to a database. So here we would have the component that would be running on these devices would be the web client. In that case, it would be Safari that would be running on Mac, and Internet Explorer would be running on PC. Now, on these devices, we would have the web server component. Now we know the web server is a software. Now you probably heard this multiple times in different courses. I'm just gonna remind you, when we say a server, or with a web server or any type of server, so the word server would like, if we are gonna use it accurately, it should refer to the software that acts as a server that receives the request and sends a response. But when you install this software in a device or in a machine, the entire machine would be called a server as well, or we can call it a host. Okay, but the web server is a software that would be running on that host or that device. Here we have a database management system, okay, that would be running on this device. Okay, so this is we're not talking about the components that are part of the system that you are developing. We are describing how a web application with the connectivity to the database would look like. The general deployment of a web application with that connects to a database external to it. Okay, now the third element in the diagram is the communication path. Now you see, remember we needed to know what are the devices, which component is going to be running on which device, and how these devices are going to be communicating. Obviously, communication between a web server and a web client happen through HTTP protocol. So this line indicates here there is a communication happening through the HTTP protocol. Now, the communication between the web server and the database server, there are several protocols that can be used in this type of communication. One of them is JDBC. So this stands for Java Database Connectivity. So what we are seeing right now here is that we are saying that the web server would be running a Java-based web application, and it will be connecting to the database through the JDBC protocol. Okay, now let's go back to our map, our My Trip subsystem, and see how we're gonna create a deployment diagram for its mapping. A reminder, this is these are the models that we have, and these are the subcomponents that we created when we have our first heuristic. Okay, so we have two components. Now, if we look at the requirements, there is a mention that these components would be need a web service. I mean, the planning part would be happening through a web service. So we're talking about web-based application, and the planning would be happening on the host, connectivity through the internet. And the routing part would be happening on the onboard computer. Now we can map this to something we are familiar with. Think about the Google Map or the Apple Map in your smartphone. So the map on the phone would be, so we can think of the phone itself as the onboard computer, and the map would be similar to the routing subsystem. And then this map would need to connect to the server and the server will do the calculation and all that through the internet. Okay, so based on that, we would need something like this. Now see, a web service needs to be running on a web server. So from the server side, we already know that we need a device or a machine, either physical or virtual, to be hosting a web server, and then our application would be running on that web server. So in that case, the web server becomes an execution environment to our component. So that's why we here depicted as a node. Okay, and now our component, which is the planning subsystem, would be running on that server or on that node. Okay, now on the client side, this is the onboard computer. Now we don't need a browser here, so think about the map that you have, let's say the Google map. It does connect to the server, and the server is a web-based server, but that doesn't happen through a browser. Okay, so the application itself is the client. So that's the case here. We don't have a web browser or a web client. Our application or our component that would be running here would be acting as the client. Okay, and this is a web server, so the communication would be based on the HTTP protocol. Okay, now looking at this, we realize that we need to do some refinement. Remember the problem with the common classes that we have here, that we were wondering which where to put them because they are needed in both components. And then we went with the decision to put them in the planning subsystem. Now, the question is, how is the routing subsystem going to access these objects, the objects of these types, if it's gonna be running on a different machine? So based on that, we realized that there's something missing here. Some sort of a communication need to be handled between those components so that the common objects would be communicated. Okay, so one way to handle that is by introducing a new component, let's say communication subsystem component, that you would have a version of it running on the server and another version of it running on the client, and all the communication would be handled through this component. Okay, so we also need to add extra elements in the routing subsystem. So I'm not sure if you're familiar with the proxy design pattern. The proxy pattern is like when you have a heavy load object, you can have a lighter version of that object. So that lighter version of the object is treated the same way. So it would be of the same type of the here trip. So we have trip and trip proxy. So both of them would inherit from the same parent. So they would be treated as the same or as of the same type. Okay, but because not everything in that object would be needed here, so that would be just a lighter version of that object. Okay, because this would be just one what is needed for like a partial part. Okay, so for one specific route, not everything known about that trip would be needed for in the routing system. Okay, so we can introduce a proxy for the trip and a proxy for the segment that is a lighter version of the trip and the segment here. And we can introduce this communication subsystem that would be responsible to send what is needed from the planning subsystem to its lighter version in the routing system. Okay, so that would be a refinement that we considered, and this is the new version of the design so far.